How does a computer know that Q and U always belong together, or that a cat and a dog are similar? The answer is simple. It builds a giant cafeteria, a social map where every letter and word gets a seat. Picture a huge school cafeteria with thousands of tables. Every single student gets a seat. This cafeteria is what we call a vector space, the floor plan where every piece of language lives. The AI builds this map by watching how words appear together in real sentences. Each student represents one letter or one word. The letter A gets its own seat. The letter B gets its own seat. The word cat gets its own seat. Where they sit depends on how they are used in real life. Words that show up in similar sentences naturally end up near each other. In any cafeteria, friends sit at the same table. So Q and U, who almost always appear together, get placed at the same table. Cat and dog, who both describe pets, sit close together. But banana sits far away, because banana is a fruit, not a pet. Instead of saying row 3 seat 4, the AI gives every student a list of numbers called a vector. For example, Q might be the numbers 0.5, minus 0.2, and 0.9. This vector is the exact address of the student's seat on the social map. Every single word has its own unique vector. Numbers help the AI measure distances. If two vectors are close together, the two words are similar. If they are far apart, the words are different. The AI can quickly say, Q and U are only 0.1 apart, so they are best friends. But cat and airplane are 5.0 apart, so they have nothing in common. When the AI sees the letter Q, it looks at Q's table in the cafeteria and notices you sitting right beside it. So it guesses. After Q, the best next letter is U. The AI doesn't know English grammar rules. It just knows that on its mental map, Q and U are neighbors. Over time, the cafeteria sorts itself into neighborhoods. All the animals gather in one corner. All the colors gather in another corner. All the numbers gather together too. Nobody plans these neighborhoods. They form naturally, all on their own, based on how words are used. Here's the clever part. The same word can sit at a different table depending on the situation. The word bank near river sits with nature words, but bank near money sits with finance words. The vector space captures these different meanings just by where the word is placed. And it doesn't stop at single words. Whole sentences get their own seats too. Sentences with similar meanings sit close together. For example, the cat sat on the mat, and the kitten rested on the rug, would end up as neighbors in the cafeteria. This social map is how AI translates languages, answers questions, and finds similar documents. When you ask something, the AI simply looks for whatever is sitting near your question on the map. The closer something is, the better the match. So here's the whole idea. A vector space is a giant cafeteria where every letter, word, and sentence has a seat. Similar things sit together. Different things sit apart. The AI uses this map to predict, compare, and understand language, all by measuring the distances between seats.